Hi, welcome to our session today. This is a re-recording of a session that ran live at both our UK and US user conferences. It's primarily on the benefits of our master data management and data warehouse automation products. And the audience was essentially people from the agility side of the house that maybe weren't as familiar with these other solutions from Magnitude. My name is Stephen Pace, and I've been associated with these products for over 20 years now. I was on the development team for about a year in London, and now supporting the team in the U.S., and I'm a senior solution architect. So we're going to start talking about the benefits of data governance, and that's really the behind-the-scenes and underlying philosophy of how our data warehouse automation product and our master data management products work. And so we're going to start with that, and then go into the data warehouse automation product, and then finish up with MDM. Now, why do we need data governance? Well, of course, we hear these types of things all the time. You know, you hear it from inside the company, you hear it from the business side, the IT side, and really all levels of the organization. And in fact, we've heard the same things for several decades. Business users can't get the information they need in the time they want it, or maybe the demands that they have are growing exponentially as new systems get added, or maybe there's too much data in some areas. You know, there's plenty of data, but it's hard to make sense of it. And why does it take so long from the time the business gives you a requirement to the time you can actually get a report out of it? You know, one aspect of not having good data governance is bad data creeping into processes and causing problems downstream. So I'll give you a couple examples. We had a customer in the CPG space. They converted to a new ERP system. Everything looked like it was good, and they were back up and running, and they put in a big order for an ingredient to be it was going to be going into one of their products. The people that ultimately ordered it thought it was a little unusual, but they went ahead and processed the order. Giant tanker truck showed up at the manufacturing location, and instead of the ingredient they thought, it was a completely different ingredient that basically meant they had to shut down their line, reorder the ingredient that they needed, and pay the extra cost to try to accelerate that to get there. And it was just because of a code translation. So as when they upgraded to the new system, just there was some codes that were transposed, and so when the order got put through, it looked like it was a real product, but turns out it was something completely different. Another example of this is one of our banking customers. The woman that ran the division, she said, I'm seeing all these quality problems, and she went out and told her staff, go out and find all the places in all of our systems where my name is in there, and I want to see that. And so they brought it all back, and they found 6 different places she was in there. She had a kind of unusual spelling of her name, and turns out there was misspellings and all different kinds of things, bringing it together. And then she looked at it and said, nope, you missed one. And she pulled out her ATM card and showed it to them, and it was spelled even different from the ways that they had just brought her. So there must have been in some other system somewhere out there. So, there's a lot of money, millions of dollars are lost every year by data quality problems that are causing downstream operational issues. Now, if you're lucky, these data quality problems don't end up in the news, and often when they do, they're quite, embarrassing, or millions of dollar problems. And the one that most people are familiar with is the loss of the Mars Climate Orbiter due to a mismatch between English units and metric units. It was a $125 million spacecraft that just burned up on Mars due to just a kind of a silly error. But one that's perhaps more near and dear to my heart is we knew after Hurricane Katrina that the flood maps had a lot of issues, but they were still working on those and kind of debating on what to do when Harvey hit Houston, and that's where I live now, and half my neighborhood was destroyed when they opened up one of the dams, and they knew it was going to flood out some people, but they needed to protect the dam itself. But that wasn't the main issue. It's that because the flood maps were wrong, some people weren't even in the 500-year floodplain, and they had neglected to get flood insurance because they thought, well, I'm not in the floodplain, don't need it, my mortgage company doesn't require it. But yet, many of those houses flooded for the first time since they'd been built in the 60s in this, huge, unprecedented event. Now, the information difference actually ran a survey, and they said 1 in 5 companies estimated that bad data cost them over $1 million annually. Now, what the most interesting aspect of that is 60% of the people checked that they had no idea how much bad data was costing their business. So, you don't really know in that case, is it a small problem, is it a huge problem, or is it slowly killing you? Now, I don't want to belabor this too much more, but IBM did a study a number of years ago that said bad data cost the U.S. economy $3 trillion per year. And now you may wonder how that could be if the entire U.S. economy is $19.4 trillion in 2017. And so this guy, Thomas Redman, he did he went and he used a bunch of assumptions, and he used a lot of more conservative assumptions that maybe some in the IBM study did. But even that, using conservative assumption, he came up with $2 trillion a year. So, if depending on your assumptions, you could get higher or lower estimates. But I think we can all agree that this number is just unacceptable. It is a huge problem. Now, if you don't get a handle on this, the problem is data volumes are doubling every 2 years. So if you're building new applications and you have new data repositories, you're gathering all this additional data, and if a percentage is bad, then now as it grows, it's going to continue to get even worse, and eventually it's going to be hard to tell the good data from the bad data. So good processes fed by bad data still leads to a bad result. So our goal here is to improve the overall data quality in the enterprise. Quit sending duplicate mailings. Stop ordering the bad products that shut your manufacturing line down, and overall improve our decision making. And so that's really the goal of this data governance program. So how do we help this? So Nucleus Research did a study they called the half-life of data, and it basically said that most organizations destroy the value of data, and not because they want to, but because data naturally decays. So if the average person in the U.S. moves 11.4 times in their life, if you're looking at an address record for somebody and you haven't updated it in a while, what are the odds that record is still good? So it's like as data moves like a conveyor belt in the business, it's consumed by the end users and reports, but often it could be too late to be of value if it took you a long time to collect it, or maybe some of the original requirements were misinterpreted. Or maybe changes in the business have now said, I've got a piece of data, but now that sales rep's in a different sales organization, and that transaction should roll up in a different hierarchy. So changes in the business and just simple passage of time are sort of like a toxic brew for data. And the hard part is it's not like fruit. You can't see the data decay. It's digital. It's not organic. But at the same time, you're looking at it. It's not good. It's old, it's outdated, or it's just plain wrong. So what business would like to do is to maintain that intrinsic value of data and build on it through context and relevance as it relates to the business. But that's very difficult to do with traditional methods. And it can really only be done by thinking differently and disintermediating past methods. So our approach is really 3 pillars. It starts with business rules, you add on governance processes, and then you have a layer of audit and control. We're going to talk about each one of these. First, it starts with the business rules. Data validation rules help ensure that you have clear and precise definitions about what constitute valid data in your systems. So for example, what is a customer? Is General Electric a single customer, or is it each division, GE Appliances, GE Capital? or maybe geographic regions of GE, their customers. So you have to come up with the rules about, what makes a valid piece of data. And in addition to just the definitions, it could also be rules about completeness and accuracy. So for example, a customer must have a credit rating, or a store's area must be between 1,000 and 100,000 square feet. So if suddenly you get a piece of data that's got 1 million square feet, you want a human to look at that and say, is that really right? Could that be possible? Or maybe we have some kind of unit conversion error. Other examples could be like a deliverable location must have a valid address. If you run it through some sort of address harmonization and the system says, hey, this may be a valid address, but doesn't look like it's real, or the zip code is wrong. That zip code doesn't exist. So flagging that type of thing. And the other part is data existing in hierarchy. So you might say a customer has to be in a customer type, or must be allocated to a region, and if they're not, that's going to break some downstream processes. So I want to make sure if that happens, for some reason it should never happen, but it did, that I have a process for dealing with that. So, kind of think about this like a firewall for your data. So these validation rules are setting up this barrier, and it hits this barrier, good data passes through, bad data gets rejected, and then, at that point you can start dealing with it. So the second pillar is data governance processes. So these need to be defined for data authoring and enrichment, correction, mapping, authorization, publishing, so forth. And it's basically needed is a series of steps or processes to deal with the rejected data and to make sure that the data is treated and followed up upon. And if it doesn't happen, maybe it exceeds some service level agreement, it gets, a notification gets sent out so that there's some oversight to the process. And as part of that activity, people need to be engaged and held accountable for making sure the data is accurate and consistent. So somebody owns this data, is responsible for this data. And the governance process then give context for those people involved, and it should also provide all the triggers for that activity. So sending somebody an email or some sort of notification when a piece of data flows in that they're responsible for. The third pillar is audit and control. So as you're running processes that can have a big downstream impact on your enterprise data assets, you want to make sure you've engaged the right people, and you also want security. So you want to know what has changed as part of this process. You want to make sure you're able to differentiate between changes to bad data and data that's just now different for some reason. And you may want to preserve the history of the valid values for reporting in comparison with what's happened. Probably the most important consideration is being able to certify and prove valid data for compliance purposes. So things like Sarbanes-Oxley, where enterprises need to prove their data is accurate and meet a certain standard. We've certainly been brought in cases where a customer's been audited, and maybe they have the Big Four consultancy comes in and says, you've got Excel in this process. And if somebody changes something in Excel, that's getting reported down to Wall Street to say, that this is my revenue number, but there's no record of who changed that cell and, what the impact of that is. So we've had to come in and make sure, bring that level of auditability to be able to meet those requirements. So Magnitude offers a complete platform for a fully governed information infrastructure, and it starts with a high-level business information model, and that model encompasses all of the rules that need to guide how data is incoming, sourcing the data, validating the data, integrating it, harmonizing it, storing it in the relational database, and then presenting it in a way that BI tools can easily consume. And across all of that is that layer of audit and security and governance for things like workflow. So with that architecture in mind, we're going to start talking now about our dynamic information warehouse product, which is a data warehouse automation solution. Now, we pioneered this market in the late 90s because up to then, we kept running into these issues as we were building data warehouses in the conventional way. And these things took a long time to build. There's a guy named Ralph Hughes that's written a number of books on agile data warehousing, and he had a 3-2-1 rule, which is $3 million, 2 years to get your first report. And, Gartner had similar metrics, like 16 months for your average enterprise data warehouse, and also millions of dollars. And so that just became prohibitive to many businesses because they were having a lot of failures in the space because it would take a long time to build, and by the time you built it, they were obsolete. The business has changed. They've upgraded to a new version of the ERP in the meantime. They've reorganized. They've sold off part of a business. There was a lot of human manual processes, so human error could creep in. People would mismatch fields and so forth. And so, we realized at a certain point there had to be a better way because we were spending as much to build it the first year, and then we were spending as much to maintain it the following year. And that just at a certain point the business says there has to be a better way. And we said, well, actually there is. We can drive this process in a more automated approach. And so we essentially built the solution, piloted it, had a lot of success, and then started expanding and selling the product outside. And then we eventually spun out to become a separate product. So our mantra here was we wanted to build the solution right. And the way we did that is we had a model that we used in collaboration with the business and IT to define what it is we were going to build. And then we would press a button, and then that would automate in basically a templated approach the actual physical creation of the data warehouse, how data get populated. So it allowed us to build it fast, go back to the business user and say, hey, this is a requirement we heard from you. This is what we're, our first cut at that. And so within a typical 90-day deployment cycle, using agile development processes, we would go back to the business 2, 3, 4 times within that to validate that what we were building was what they really wanted. And then by virtue of how we were building this in this model-driven way, it was really built to last because you could change the model and it would change the system. So rather than think about how hard some of these processes, because they're built with these manual processes, how hard they were to change, and now suddenly you go in there, change a few pieces of essentially metadata in a report in a model, and have that thing automatically get instantiated into the system. So our elevator pitch for Dynamic Information Warehouse, which we call Information Engine, is sort of the thing that encompasses both DIW and MDM. But for the purposes of this, DIW is essentially this high-level business model. So instead of physical data modeling, this high-level business model, it's coupled with software automation. So that model essentially becomes metadata that creates the solution. So we take industry best practices, and then we do all of the things you would have to do in a manual way, but we automatically build the warehouse, we build standard schemas, and then really allows us to accommodate business change in hours versus months. One of the examples I always like to tell is one of our pharma customers, they actually had a change to their fiscal year. And for all of the parts of the business that didn't use DIW and didn't use model-driven approaches, it was like a Y2K type of problem, having to recast all the reports using the new fiscal calendar. And so the woman who was running the warehouse in this one division got called in, and they said, hey, here's what we want to do. She said, okay, sounds good. And she went back over lunch. She made some changes and came back and said, okay, I'm done. And they said, wow, you're done with the estimate for how long it's going to take. It took the other groups a long time. She said, no, I'm actually done with the change. And by virtue of how we did it, I can report using the new fiscal hierarchy as if it had always existed. And I can also give you the historical way of it, how it used to work at the same time. And they were blown away. And it was sort of at that point that she realized she could have taken off for a couple of weeks and come back, and they would have been happy to have it done just in a couple of weeks, much less just over lunch. Now, in the late 90s, when we were first building the solution, if you went to the Data Warehousing Institute or you got some books on data warehousing, they would sort of lay this out as a best practice architecture. So you have a bunch of source systems, you have some extract, transform, and load processes to stage up the data, maybe some more ETL to build a third normal form, typically data warehouse, potentially some more ETL to build out subject area data marts that typically were like star schemas, and then configuring the BI environments to be able to see those star schemas and then generate the reports for the end users. And this required a lot of knowledge, and in fact, also a lot of people in different groups. So when we were building this, the people that maintained the data warehouses were different than the people who originally built them, were different from the BI team, might have DBAs that would be the ones changing the tables, and they're different from the ETL team. So every time you had a handoff, there was a context switch, there was maybe a chance to get something wrong. And then once you eventually build it, imagine if somebody comes along and says, hey, I have a new attribute I need in my report. So you'd have to work out, okay, that I'm going to have this adjusted here in the reporting schema, which means it needs to live here in the data warehouse, which means that some of these ETL processes have to change. Where do I source that new bit of data? Is it somewhere in a source system, or maybe it isn't? Maybe it's in the VP of Marketing's head somewhere, and they have to give us an Excel file, and so there's no place for that data to come in. So it needs a home. And it's sort of like if you were putting up forms and rebar and pouring concrete. As soon as you need to have a change to one of those requirements, you have to get out the jackhammers and start changing it. And that's why the change was so painful in some of these large enterprise data warehouses. So what we're doing is saying, rather than this complexity and inflexibility and cost and time that's ultimately obsolete by the time you go live, if we can automate this and build this out using this model-driven approach, you're going to be able to get there much faster and then get back to the business users and say, is this what you want? And then start delivering real value sooner, and then be able to change what you ended up deploying. So, in this way, we can manage every kind of data. We're agnostic of source. It's very easy and rapid to prototype and implement, easy to change. And because of this behind the scenes, we're tracking all the changes, who changed it, when they changed it. So you can report using any hierarchy that's ever existed down to the second, which is why we got a lot of take up in regulated industries. Like pharma and insurance, with full, complete data stewardship and governance in the background, as well as audit trails. So at a 50,000-foot view of our architecture, then, we have this high-level business model that you press a button, it becomes metadata that then describes all of these things. It builds the staging areas. It potentially builds a master data management app. It has potentially workflow. It has what happens when the data does not fit these rules. How do we reject this data? Do we reject it to tables? Do we have a nice wizard that we can present to people of why the data rejected? And, along with a complete information engine, being able to route that with workflow to data stores to be remediated. So essentially, everything that you need to build the data warehouse or a data mart or a master data management system. And so at a 50,000-foot view, this is the architecture. This is how we're able to be able to change the system so fast. Now, what does a business model look like? And this is really where everything starts. And so this is the cutaway of a business model. So in here, the square blue boxes represent reference data and master data. And so in this example, we have a customer dimension that has three hierarchies: parent company, this industry classification, and a geography component. And you can start to see some of the business rules that are being validated. So in this case, if you see a solid line, that means it's a mandatory attribute. If you see a dotted line, it means it's an optional attribute. That means if I get a customer record and it's missing region, if region is null, then that's okay. It'll allow me to load that data. But if there is a region supplied, we do validate that it's in the valid region category. And there's other complexities going on here. I don't want to focus on everything, but in this example here, we call this an involution or ragged hierarchy, which means at design time, we don't know how deep this hierarchy is. And maybe we load from system 1 and it's 2 levels, and we load from system 3 and it's 3 levels, and that's okay. This one little piece of, this little arrow here just says that that's okay for that to be a variable depth hierarchy. So these are the dimensions. We've got customer, we've got time, we've got product, we've got internal organization, we've got multiple hierarchies. There's no limit on the number of hierarchies you can have. This is a business rule-driven hierarchy here we call mapped business entities, where you can take out multiple dimensions and say, maybe in France I want to see this particular washing powder rolled up this way, but in the UK I want to see it rolled up a different way. And then these colored boxes with the rounded corners represent the transactions or facts that we're capturing, typically business events. So we have a sale for sales quantity and revenue, and then we can follow the arrows here and say, okay, in this case, we've got sales quantity and revenue by customer, by day, by person, by product. And then we have sales targets at a higher level. So we have sales targets by country, by quarter, by product. Now, maybe the business comes along and says, hey, I now want sales targets by region. And then you can have that discussion. You could say, well, I could give you sales quantity and revenue by region because I can aggregate up to that, but I can't give you target sales by country. But I can grab this arrow and move it down, but that means there's a change to the business process that says you now have to give me target sales by region because maybe today you're only giving it to me by country. Now this BIM business information model also can represent the attributes that are part of the different categories. So in this case, we've got an attribute of unit price, so we can display it on there, and that's fully configurable on the right-hand pane of this. And by the way, Business Information Model is a free product. We have it on our website. You can download it. What we charge for is the button that actually deploys it and creates the system. So if we look at the next tab, so that was the diagram tab we were looking at. If you shift over to the Operations tab and you say, I want to deploy this model to the original warehouse, and then you say Start Deploy, there's a web service there that it's listening for saying, hey, there's some changes coming in. And in fact, if you click this button of View Local Changes, it would actually show you all of the changes that are going to get deployed. And it can do that, just showing you the incremental difference. And if there's any changes that happen in the development side, you'll get a real-time notification in here by virtue of a little red exclamation point saying, hey, somebody's made a change over there. Would you like to sync those changes back into this model? But essentially, that's the process. You go over here, you hit deploy, and then at that point, the software automation wakes up in the development side, because this is deployed within the framework of dev, test, production. The software automation wakes up and says, well, based on these changes, I need to make these physical changes to these tables, and then it just makes those changes for you when you're ready. Now, the types of models we support, I just showed you a simple cutaway, but they can be very complex, types of real-world models. We've got companies like Unilever and Philips Electronics and Comcast using these models. And if you look at this, you can see there's tons of attributes. But in this case, we've got multiple levels of subtyping and supertyping. So we have a concept of a security that then could be a fixed income security or a derivative. And in this case, the fixed income inherits all of these attributes for the supertype and has a lot of them that are specific to just fixed income. And then even within fixed income, you could have inflation index, you could have mortgage, municipal, or bank debt, and each one of those has some specific attributes to itself. And then this delivery type then actually applies to all of them, because we can see it applies to the supertype, but then you could also have parents on any of the subtypes as well. So this is a real model. Now, over time, maybe in the first phase, you're going to deliver a number of dimensions. So in this case, we've got customer and product and time and sales organization. And then you see a number of fact tables here. So these colored boxes with the rounded corners and the arrows. And then within BIM, you can hover your mouse and then it can hide all of the other arrows. Or there's settings that you can also hide it to make it a little bit more easy to consume or describe to the business. And there's also subject area views. So I could have just the marketing view or just the HR view, and by presence in the global overall model, you still have everything in there, but then you can have a very focused model where you just talk to the people who are maybe giving you the new set of requirements. And that's at a high level, how the system works. So we've gotten the books from the industry. So you go look up industry best practices books from Bill Inman or Ralph Kimball or Ralph Hughes. And then we basically encompass those best practices in the system. So how do you deal with ragged hierarchies? Or how do you do matching and merging, or hierarchy management, or browsing through the data, or knowing how to build a star or snowflake schema, managing the physical schema, slowly changing dimensions. All of these things are things that you had to know in the old days to build a successful data warehouse. But now we've wrapped those things in a data warehouse automation solution so that you don't have to be as much of an expert. You can just follow along with the wizards, and then the system does the thing that you should be doing in the background. So we're just automating each of these and more of these items. So that's the data warehouse automation solution. Now we're going to focus on our every domain master data management solution. So where we came to MDM is we were originally in support of a data warehouse. So, we're building a data warehouse. We want to have corporate performance insights, which means we have to have good data. And so I've never run across a company yet that when we set all these rules and we start loading the data, that all of the data just loads perfectly. And in fact, we have a lot of rejections, and so we have to start dealing with how do we look at this data that's rejecting and help the business move forward and make it valid. So we talked before about the firewall for your data, for bad data, and so this is what's happening with the data that got rejected. And before I move on to this, while we came at this originally from the corporate performance insight, it turns out master data management is also involved in operational processes and regulatory compliance and other things. And so our MDM is really agnostic of any of those use cases. We're obviously very good at supporting analytical types of MDM requirements with data and hierarchies and the validation of that. But also, over time, we've added a lot more operational use cases to make sure that the data in your operational systems is meeting the requirements to be able to do the things, to order the products, to pay the vendors in a timely manner. And this isn't easy. And why is it not easy? So the good news is we have a lot of data to answer these questions, especially on corporate performance insight and operational management. But the bad news is there are some fairly substantial barriers to answering our questions. And what are those? Well, first, the number and complexity of source systems. So as we talked about before, there's more data sources than ever before. And even the complexity of a single source can be overwhelming. So one of the companies that's part of Magnitude originally is Noetics, and they have a lot of knowledge about Oracle EBS. It's one of the most popular and widely used ERP systems out there, and it has over 20,000 tables. And so if you want to access that data, you need to know a lot about the system, to know where stuff is, to know what it means. And so you spend a lot of time and energy extracting the right data and assembling it in the right way. And many IT organizations don't have the knowledge to do that for a single data source, let alone many. So that's one problem. Second problem is these source systems are changing, and it's not only because of more systems being added because of mergers and acquisitions, but there's best of breed strategies, and now especially cloud strategies. So existing systems may be changing, but even relatively simple version upgrades can upend your current ETL processes. So you're pulling data out, now there's some new fields, well now you have to go back and change those extraction routines. And so keeping up with those changes can be very difficult, and especially when you start adding in the cloud and complexities there. There's Salesforce.com we use internally, Concur we use internally. Well, there's new releases of that almost every quarter, and which brings with it new functionality, change functionality, new fields, which may need to be accommodated. Now, additionally, there's few standards, and the standards there are usually poorly enforced. So there's probably some data standards out there, but it's rarely or as broadly or well defined as you might think. And there's typically very few standards that are defined across all systems, and even fewer that are consistently implemented across all systems. And part of this is because over time we've learned that the more you customize an operational system to your specific requirements, the more expensive it is later to go and upgrade it. So if you roll out a relatively stock ERP, then you're going to have a relatively stock set of rules, and those rules are not going to match across systems. And part of that is it's right that they don't match. There's a different model in each system because they're doing different operational things. So for instance, in SAP, you may have information about somebody that is a customer, but in Salesforce, you might have some information about somebody that you want to become a customer in the future. So it's prospective customers. And so they have a different model because they're doing different things. So, even if the data is correct, and if you're assembling data from different systems, it's sort of like an apples to oranges comparison. So you can't just simply aggregate the data together without some sort of effort to standardize and harmonize the data. And last, there's unknown data quality in these systems, lineage, auditability. we can suspect the data is bad, and you could hope that it's good, but without some type of measurement, it's really difficult to know, what am I taking on when I'm absorbing data from the system? And there's some strategies that you can use to deal with this, but if you're dealing with a homegrown system that's spaghetti coded and handcrafted that 20 years ago, it may be very difficult to maybe notoriously difficult to go and test and figure out if it's really working as advertised. And add all those things together, well, the business keeps changing. So you're going to absorb this data, systems themselves change, but the business is going to say, well, you know what, we used to be, mainly brick and mortar, now we're doing more in the cloud and selling on our internet store, so that brings in some different attributes, different metrics that we didn't have before. So even if you're doing everything right, the business is evolving, competition is increasing, more data sources are out there in the cloud that you might want to incorporate. So organizing data is a universal challenge. One of these I'd like to call out is, the cost of any given business analytics products. It's a good chunk of that, and for a long time, Data Warehouse Institute was quoting an 80% number, and this survey has the same number, but it basically says 80% is actually finding the data and organizing it. Now, we have a number of strategies at Magnitude that can help you with that. We've just recently announced Magnitude Gateway, which takes some of the smarts and that we've built over the years as part of our Noetics and Datalytics platforms of knowledge of source systems and building it into connectivity through our Simba division, so that you can, instead of just pointing your BI solution at 20,000 tables that don't make any sense, you open up like subject area views. Like, I want to open the HR module, and I want to find employee, and I want to grab these three attributes, and it's in business-friendly terms. So there's certainly things we can do to help on sourcing the data. But once you source the data, you still have the problem of harmonizing it and bringing it together and making a golden copy. And that's really what our MDM product is designed to do. So sometimes we call this the 3 A's. And this is kind of at a high level what Magnitude's oriented around doing is, and the first A is access. So data is going to be coming in from more sources all the time, and so we have expertise in the ERP systems like Oracle ERP and JD Edwards and SAP, and increasingly things are moving to the cloud. So we have solutions for being able to read from Concur and Salesforce and other systems. And then there's systems out there in the cloud you may need to pull data together, and there's also increasingly interesting things from the Internet of Things and big data that's sitting out there in a data lake and needing to connect to it, bring the data in, and analyze it. So there's the access part. But after we provide the physical and logical connection to these various data sources, the next A is analyze. So we can't just throw the data together from these different sources and hope it's going to be good enough. We've got to, include these non-standard and incomplete data sources, outdated, duplicated data, and without some type of work, it's just going to be unusable. So as part of this center cube here for prepare, there's harmonization. So that's the process of blending data from different sources through matching processes to identify and remove duplicates. And in parallel, there's governance processes that are required to define and enforce the business rules and standards across all the data, and provide some type of remediation for that data if it doesn't meet the standards. So that's really the workflow we were alluding to before. And then, once we know we're working from a consistent set of high-quality data, then the data can then be prepared for analysis. So there's a lot of things that can happen there. So we need to put it in a format that the BI tools are going to like. And so ultimately we're going to deliver that into star schemas or some mechanism for them. But basically the last A then is act. So being able to take those good sources and make some decisions based on the reports and dashboards that are being fed. Now, today I'm going to focus on this middle cube here under the prepare and harmonize. So we talked a little before about data quality. Well, if you have incoming data that looks like this, is this one company or 10? Some of this, well, clearly, we have IBM and IBM with spaces and spelled out. Maybe it's one, or maybe it's more than one. Maybe there's a head office and then there's some subsidiaries here. So the answer is probably going to be somewhere in between. It's not going to be one, it's not going to be 10, but it's going to be some other amount. And we need some business input on some of these. Similarly for product, is this one product or is it 10 products? And then once you go through the kind of deduping process, now we need to harmonize that and have one version, a golden copy of this record. But if you have 5 IBMs here, well, maybe under address that's pretty easy. Although, in this case, we've got a Colorado Springs address and we've got a White Plains address and even a couple versions of that. So we need to determine, for instance, if the White Plains, this record here, they're paying us on time, but a couple of the other ones aren't. When we surface that up to the golden record, we're going to classify the golden record with the customer status. Which one of these are we going to choose? And in some of these, we don't even have a value. So this is, coming up with the rules in conjunction with the business to determine which one of those is going to basically persist in the ultimate golden record. Now, to do this, we have essentially three modules. The core module is the thing that has the workflow and all it accepts the business model and then starts absorbing the data, the workflow, the hierarchy management, all those kind of core every domain MDM functions. Now, over the last 2 years, we've been spending a lot of effort on improving our harmonization. So we've added this harmonization wizard that not only has advanced matching capabilities, but also the survivorship to say, if I'm taking data from 3 sources, for each attribute, which attribute should survive in this process. So maybe I trust Oracle EBS more for the finance-oriented data, but for the marketing data, I might prefer Salesforce attributes. So if the attribute came from Salesforce, I'm going to take that one. So if there's a conflict between the two for the same amount of data, I'm going to use the rules that we create to work out what data is going to survive. And last, we have the ability to create operational systems on top of MDM, which we call MDM Workbench, which are essentially customized UIs that allow you to have the data look the way it needs to look, maybe combines data from multiple categories of data, and essentially allow the data store to work as they need to work. So for companies like Anheuser-Busch, they author new vendors using a Workbench application, and they have a very sophisticated process for how that happens. They had specialty requirements, like there was a team in China that was doing this, so they needed to press a button to be able to convert automatically between English and Chinese. And so we built a customized screen using MDM Workbench, so it can leverage all the under-the-cover core capabilities, but then present it in a way that the business actually needs. So it basically allows you to engage a broader community of people that maybe aren't trained in core MDM, but are trained to do a very specific function, like onboarding new vendors. Now, the core capabilities of it are essentially we're in every domain. So we're not just Link, we're not just a PIM tool. So those of you coming from Agility, it's very strong in the product information management and digital asset management side. But in this case, we're talking about taking all of the core attributes of any piece of data, whether it be customer or product or vendor or item or location, and defining that, and then having the system be able to onboard that, and then define the model using this high-level business information model that we showed before, integrating the workflow, building these customized screens if you need to, and we also have, as we saw in the data in the DIW or the Dynamic Information Warehouse section, the ability that once you have that clean data, to be able to write it out in a form that BI tools can easily query. And last, we could deploy this on the cloud or on premises, or you can move from one to the other. It's the same code base in each place, so you have a lot of flexibility for how it gets deployed. Now, just briefly, for each one of those, so we saw some examples of some models before, but what we mean by this is it's very easy to create a high-level model that becomes the common language between the business and IT. This model is understandable by the business, so it's at a conceptual model level. It can support real-world complexity, and for many of our customers, they'll print this out and they'll hang it on the wall of their cube or their office, and then they'll come back with IT and say, hey, in version 2, I want to, and they'll start drawing new boxes and new lines, and then that'll get onboarded into the next phase. So Anheuser-Busch, I mentioned before, they have over 250 different classes of master data managed in their system. Comcast, they have a very complex product bundling around, when you have HBO in your region, and maybe it includes HBO 1, 2, 3 and Signature, and they at the end of the year or various times they have to report back to the content owners how much money that they're owed for the different services that people have, and it's just a very complex matrix, and we support that. And as I said, we're model driven. It allows you to create requirements in days, not weeks or months, and you push a button, and then it can deploy either to MDM or the data warehouse. And you can see we support multiple levels of subtyping and supertyping and variable depth hierarchies. And basically what that means to you is if you have a complex real-world problem, we can probably support it right out of the box. And you talked just briefly on the previous slide about Comcast. They had been working on trying to solve this problem for over 18 months using some other technologies, and we came in and did a short pilot in, I believe it was just 2 weeks. And at the end of that 2 weeks, they looked at it and said, yep, that's it, and they purchased the solution and rolled it out. As I mentioned, from the ground up, we've thought about data governance and how do we bring in non-technical data stewards into the process, routing data to them via workflow, supporting service level agreements like timeouts if the data steward doesn't work it in the maybe 7-day period that the service level agreement is set for it gets escalated to somebody else. And behind the scenes, we're tracking all the audit trail and everything around this. We've got customers like insurance companies that need to change their finance hierarchies all the time. They need to have the history of those changes, but also be able to change it very rapidly. So, our GUI allows for every piece of data in the model, you get an edit page and you get a view page. So, if you give people authority to change the data, those data stewards will be able to edit it. Other people will be able to view it. But I would say every customer is using us for multiple domains of data, and this audit trail functionality behind the scenes is extremely important because you can click on any record and see a Gantt chart view of history throughout time to see, at any given time period what an attribute value was. A couple screenshots of the MDM workbench that I talked about. So we've got a variety of different customers doing this. So AUDIT maintains the matrix of shoe sizes that are sold in different geographies. We've got specialty retailers for being able to manage, basically matching the people that source a product or make it with the people who want to buy it and label it for in-house brands, and so a lot of very sophisticated, easy to use screens built on top of our MDM application. We mentioned also that once you have good data, the next thing you want to do is start reporting on it, and we're the only MDM tool that I'm aware of that has its own data warehouse automation solution built in. So that's very powerful because that's almost always the next thing you need to do after you get good master data is have good reporting. Now, some of our customers start with data warehousing, realize they have bad data, and move to MDM. Others start with MDM, solve a specific problem, and then get into reporting. But almost all customers have those. Now, we're agnostic, so if you have an MDM problem that we're solving for you, but you already have a data warehouse and a different technology, certainly that technology can just read the data from us. But if you're building a data warehouse from scratch, especially if you have a small team and not a lot of experience doing it, we're a very good add-on solution to your MDM to be able to do the data warehousing as well. And last, have a slide to kind of explain the deduping and harmonization process. And so what I'm showing here is ingesting data from 3 different systems. So imagine we have SAP, Oracle EBS, and Salesforce.com, and we have various records in each one first thing we have to do is figure out, is there duplicates within that? And so it may be that if there's two records over here, we decide that even though, like, my name is Stephen Pace, but maybe I'm in there as Steve Pace as a second record, we're going to ultimately realize that they're really the same person. And so we're going to merge them together. So we're going to dedupe first. And after we do that, we need to match and say, well, we had in EBS Stephen Pace, and in SAP we had Stephen Pace. So we need to make sure that we're going to match them together. And then the last step is if there's different attributes for myself in there, what are we going to do? So at this stage, we said, okay, we already had a golden record set up here, and we're going to match these incoming records with them, and we're going to use the survivorship rules to figure out which attributes are going to persist. Now over here, we didn't have anything that matched, so we're going to promote them up, these new records, to the golden record. And by virtue of seeing how there's different colors here for different attributes, you may have SAP attribute persist up for some fields, and you may have EBS persist up for other fields, and maybe Salesforce for yet other fields. And you can have a hierarchy of that, and so it could say, well, I'm going to first trust SAP, but if SAP is missing that attribute and EBS has it, then I'm going to go ahead and grab it from there. If it's missing from there, I'm going to go grab it from Salesforce. And you can mix and match, and you can change those rules over time. And that's it. So I hope you found this session interesting, and you have a better understanding now of our general MDM and data warehouse automation solution, which we call DIW. Thanks for listening.